Now, as is the common practice here, go over what I did in the MCR, but briefly. I'm not going to go over the details of this because we've done the details in class, and if you don't remember the details, then watch the MCR videos. But let's put the context down here. Okay, so the first question was, we want to find a linear function whose graph passes through these 2 points, a quadratic function whose graph passes through these 3 points, a power function whose graph passes through these 2 points, exponential function whose graph passes through these 2 points. Okay? How do we do that? Well, in the case of a quadratic function, it's exactly what we did during the first week of class. We take the form of a quadratic, and we have 2 possible forms, the general form and vertex form, or the standard form. Okay? I'll use the general form. That's what we used first, with our really first exercise. And we plug the coordinates of the points in. We get 3 simultaneous equations. If you don't remember how that was done, well, reason it out. You probably can. If you aren't sure, then you really want to look at the video where I explain it, or at least look at the result here. So you can even look at the board pictures and see the picture of this stuff here. Okay? Now, we do the same thing with the linear function, the form being y equals mx plus b, and we get 2 simultaneous equations. And we solve those equations here in 2 ways, one by eliminating b and one using substitution. And we checked to make sure that the solution checked out. And we got the same solution both ways, so the details of that we've, again, seen a number of times. So we're not going to go over that in this class. Now, the thing that everybody needs to know that I want to emphasize, okay, is that the form of the function is the essential thing you need before you can plug the points into the form, obviously. And what we do is we plug the points into the form of the function, into the form of the quadratic, or into the form of the linear in the first case. So what's the form of a power function? You should know. Okay, what are the power functions? Which of the basic functions are power functions? Well, x squared is a power function. That's x raised to a power, right? So is x cubed. Okay, so is 1 over x squared. That's the negative 2 power of x. 1 over x is the negative 1 power of x. Those are all power functions. Okay? In the general form of a power function, we stretch it by factor a. Well, we're not going to. The general form of a basic power function that hasn't been translated but that has been stretched is y equals ax to the p. Okay? So it could be x squared, x cubed, x to the negative 2, x to the negative 1, or the square root of x, which is x to the 1/2. Okay? So 5 of the functions, that's, I think, a majority of the basic functions I want you to be able to graph are power functions. Very important functions. So y equals ax to the p. Okay? Like a times x squared, a times x cubed, a times the square root of x, whatever. Your exponential functions, y equals a times b to the x. Exponential means that your exponent is your variable. Okay? Variables in the exponent. We solve exponential equations by taking logs of both sides or converting to log form, whichever way you want to see it. That's an exponential function. That's the general form of an exponential function. Now we can shift it, we can stretch it. It's already stretched by the factor a there. We can compress it, okay? But these are the basic forms. So if I want a power function through these points, I plug these coordinates in to the function and I get this equation. I plug these coordinates into the form and I get this equation. So there's a set of simultaneous equations for the power function. I do the same thing for these points with the exponential function and I get these 2 equations, right? And then we proceeded to solve, again, the system for the linear. We didn't solve the system for the quadratic, but presumably you know or can quickly review how to do that. because everybody was doing it okay back in January. And we solved this one, okay? Now I'm just going to briefly go over the solution of this system. Yeah, it's supposed to be there, but it isn't. Okay. Well, here's the system. There it is again. We plug these points into the form of the power function. We get these equations. We solve by substitution. We solve the first equation for A. Okay, well, here's the first equation. We divide by 2 to the p and we get this. And then we plug this into the second equation. Well, A is 12 over 2 to the p. Second equation is 2a times 7 to the p, so we get 2 equals what? A is 12 over 2 to the p times 7 to the p, and now we have an equation just in p. Okay? We rearrange that equation using the laws of exponents, and we get this. And then we divide both sides by 12, and we end up with this equation. Okay? If you don't understand the details of that, and you might have some trouble with that, check the videos from the MCR. Or check what we've done in class. Okay? Just application of the laws of exponents. Okay, so we get this. Now how do we solve this? Well, we might be tempted to say, okay, 7 halves to the p raised to the 1 over p, because that'll give us just 7 halves, right? Okay, well, if this was x to the p, that would be a good way to solve it. But it isn't. So what we end up with is 7 halves equals 1/6 to the 1 over p. P's still in an exponent, it's still unknown, and we haven't made any progress. So we don't do that. Okay? Tempting to do that because that's often an operation that we would do. And that's an operation we will do when we solve the exponential system, which we're going to do in a minute. Okay? What do we do here? P's in the exponent, we're trying to solve for p. What do we do? Well, that's an exponential equation, right? Something to a power equals something. We don't know the power. We change it to logarithmic form. This is base is 7.2, so we do a log to base 7.2. P will be a log base 7.2 of 1/6. And that's very straightforward if we remember how to convert between exponential and logarithmic form. Something people are doing pretty well, but you really got to be sure you understand before you go into the test, the exam in 2 weeks, what you have to do there. So you do that and you get the result. Boom, it's over. Okay?